So here is another question. So it is given that a body is moving with uniform acceleration. Its velocity after 5 seconds is 25 meter per second, and after 8 seconds it is 34 meter per second. Calculate the distance it will travel in the 12 seconds. Okay. So here you have to understand, first it is given that an object, it is moving with uniform acceleration, okay, that the velocity after 5 seconds it is 25 meters per second, and after 8 seconds it is 34 meters per second. No information has been given about the initial velocity and the acceleration. So we have to determine these two parameters. Only then we can determine the distance traveled during the nth second, which is equal to u plus a by 2 into 2n minus 1 for n is equal to 12. Okay, so here we will be using the equation of motion, the first equation of motion, v is equal to u plus at. v5 is equal to 25 meter per second, so 25 is equal to u plus a into 5 for t is equal to 5. That implies u plus 5a is equal to 25. Then we have 34 for t is equal to 8 seconds, u plus a into 8, u plus 8a is equal to 34. This is equation 1, this is equation 2. So if we subtract 1 from 2, it is u plus 8a is equal to 34, u plus 5a is equal to 25. Then it becomes 3a is equal to 9, that implies acceleration is equal to 3 meters per second square. That is the first parameter which we want. Then to determine u, we can simply substitute u plus 8 into a, which is 3, equal to 34. That implies u is equal to 34 minus 24, which is equal to 10 meters per second. Initial velocity is equal to 10 meter per second. Acceleration is equal to 3 meters per second square. Now we can substitute s nth for n is equal to 12 in the 12th second. That is equal to u, which is equal to 10 plus a by 2, which is equal to 3 by 2 into 2n minus 1, which is 2 into 12, n is equal to 12 minus 1. Simply substituting this here, this one, okay, this one. You are simply substituting the values, that's it. That is equal to 10 plus 3 by 2 into 23. 12 into 1, 12 into 2 is 24 minus 1, it is 23. So it is coming around 44.5 meters, okay, s12 second, this, okay. So first we use this formula, v is equal to u plus at, the final velocity after a particular interval of time, this formula, to determine the parameters initial velocity and acceleration. Okay, first we did that, initial velocity and acceleration. Then using these two, we substituted the values in this equation. The displacement during the nth second, we determined s nth, the 12th second, which is equal to 44.5 meters. Okay, basic application of equations of motion. Okay, so here is another question. So it is given that two particles, they move along the positive direction of x-axis uniformly with speeds v1 is equal to 8 meter per second and v2 is equal to 4 meter per second for the first and second particle, okay, respectively. At the initial instant, the first particle, it was means at the moment the observation started, okay, at that point the first particle was 21 meters to the left of the origin, the reference, and the second particle was 7 meter to the right of the origin. When will the first particle catch up with the second, and where will this take place? Okay, so we have the question. Now the next step is to draw an accurate diagram to depict the whole situation. Okay, so let us first draw the coordinate axis so that we are clear about what we are doing. So we have, let's say this, here we have is the x-axis and here we have is the y-axis. Okay, this is the y-axis, this is the x-axis, this is the origin, the reference. So here it is said that the first particle is 21 meters to the left of origin. This is the first particle, let's say. Okay, this is the first particle. It is 21 meters to the left of the origin. Okay, and it is traveling at a velocity of 8 meters per second in the positive direction, that is in this direction. And at the same instant we have another particle which is 7 meter to the right of the origin. Okay, let's say it is here. So, okay, let's draw it here. This is the second particle which is 7 meters to the right of origin, this. Okay, and this is traveling at a speed of 4 meter per second. Okay, v2 equal to 4 meters per second to the right again. So it has been asked where they will meet. Okay, so for that let us just extend this axis. Okay, so let us say they meet here. Okay, they meet at this point. Both the particles, they meet at this point. 1 and 2, they meet at this point, which is, let's say, this, after a gap of x from this point. Okay, at a gap of x from this point, the initial position of particle 2, the initial position of particle 2, after that a displacement or distance of x meters, then they meet here, and let's say they met after a time interval of t seconds, time interval of t seconds. So here if you see, particle 2, it traveled x meters. Okay, particle 2, it traveled x meters in t seconds. Okay, it is moving with a velocity of 4 meter per second. So this x meter is actually 4t, because distance is speed multiplied with time. This is very important. Okay, this. So we have here assumed that both of them met at a gap of x meters from the initial position of particle 2 after t seconds. So in those t seconds, particle 2 covered 4t, this much distance, which is equal to x here. Okay, this. So this is a very important equation. Now, for both particle 1 and particle 2 to meet, particle 1 has to cover a total of 21 meters, then 7 meters, then x meters, which is basically equal to 28 plus x meters. This much. This is the total distance covered by particle 1, which is traveling at 8 meters per second. They are traveling with uniform velocity. Okay. So in those t seconds, particle 1, it covered 28 plus x meters. That implies 8t, that is speed multiplied with time, is equal to distance, the total distance covered by particle 1, which is equal to 28 plus x. Okay, this is the second equation that we have. Now here we have already determined x is equal to 40. So we can substitute this value here, that is 8t is equal to 28 plus 40. We just simply substituted x with 40 here in equation 2. That implies 8t minus 4t is equal to 28. That implies 4t is equal to 28. That implies t is equal to 7 seconds. So it means they will meet after a time interval of 7 seconds. They will meet at a time interval of 7 seconds. And where they will meet? Okay. So here in those 7 seconds, this particle 2 will cover x, which is equal to 4t, which is equal to 4 into 7, which is equal to 28 meters. This x is equal to 28 meters, which is basically 28 plus 7 meters, 35 meters from the origin. Okay, 35 meters from the origin. So to answer the two questions that this whole this whole problem was all about, after how much time they will meet, which is equal to 7 seconds, and where they will meet, 35 meter to the right of the origin. This. Now there is an alternative method also, which is based on the concept of relative velocity. Okay, alternative method which is based on the concept of relative velocity. So you have the diagram with you. Now here, if we say V1 is greater than V2, the velocity of particle 1 is greater than velocity of particle 2. So relative velocity of particle 1 with respect to particle 2 is equal to V1 minus V2. I have already discussed the basic concepts related to relative velocity. That is equal to 8 minus 4 meter per second, which is equal to 4 meter per second. That is the relative velocity of particle 1 with respect to particle 2. Initial separation between them. The initial separation between 1 and 2, particle 1 and particle 2, that is 21 meters plus 7 meter, which is equal to 28 meter. Okay, so the time when they will meet each other, that is equal to the initial separation 28 meters divided by the relative velocity, which is equal to 4 meter per second. See here, this is the relative velocity that we are taking into account, okay. So that is equal to 28 by 4 meter per second, which is equal to 7 seconds. Same result. Here also 7 seconds, here also we got 7 seconds as the result. And same here, after they will meet after 7 seconds, and the distance travelled by particle 1 in these 7 seconds, that is equal to 8 meters per second into 7 seconds, which is equal to 56 meters. Okay, this is the distance travelled by V1 in those 7 seconds. So exactly 56 meters. If we subtract 21 meter from it, it will be equal to 56 meters minus 21 meters, that is equal to 35 meter to the right of origin. So here, why we use the relative velocity concept? See here, what relative velocity means here is that velocity of particle 1 with respect to particle 2, assuming that it is stationary, okay, that. So when we use that, we took the initial separation only into consideration, okay. But if you are not, comfortable with the relative velocity concept, then this is a very simple and straightforward approach, okay. So we assumed that they met after a time gap of t seconds with a gap of x meters from the initial position of particle 2. So here particle 2 travelling with velocity, uniform velocity 4 meter per second, it covered 4t in those t seconds. Then particle 1, which travelled a total distance of 28 plus 4t, it covered a distance of 8t. So here 28 plus 4t is equal to 8t, and finally we got basic mathematical calculations we performed, and we got t is equal to 7 seconds, and from that we determined the gap, or the the point, the location where they will meet, okay. So this is the solution.